Hello everyone. So today we are going to study about matrices. So these are the following topics that we are going to cover today. Introduction, types of matrices, operations on matrix, elementary transformations of a matrix, inverse of a matrix, followed by symmetric and skew-symmetric matrices. So let us jump right into it. Let's talk about some introduction. What is matrix and where are these matrices used? So we can see a few things here. So this is Minecraft, right? This is rocket science. This is ISRO's I think it's GSLV rocket, and here you can see some stock market graph. This is the Bombay Stock Exchange. So what do all these things have in common? Well, the basic thing is that matrices store data, and data it's easier to store in matrices because of its computational efficiency that we're going to study today. So in Minecraft, if you want to rotate your person, correct, so that time you can actually the code behind it uses rotational matrices, and that's how you can rotate things in your perspective, right? Similarly, to understand where and how exactly are we going to launch the rocket, we also use lots and lots of complex mathematics, and matrices are basically a tool that helps us to understand how these rockets are launched. Also in stock market, if you want to study the details of a stock and maybe calculate its variance, calculate its average and other things, then that time also you can use matrices. It's usually used in the form of programming. Yeah, so programming, because of programming, I think we should say we should keep an arrow like that. So by programming, you can code Minecraft, you can code and simulate rockets, you can also code how stocks work. And in program, we use a thing called arrays in which we store data, and that is how we apply matrices in programming, and that is how we use matrices all over these places. So what exactly is a matrix? Matrix is an ordered rectangular array of numbers or functions which are called as elements. It is generally denoted like this, and let's say I have, let's say 1 2 3 4. So here we have a matrix. I'll write this A is a matrix, and this matrix has 4 elements, which is 1 2 3 and 4. It has 2 rows. We call these things as rows, and 2 columns. These things are called as columns. We have got 2 rows and 2 columns, so we write it 2 cross 2, 2 into 2, which is nothing but 4 elements. So what does this 2 into 2 mean? Always it means that we have 2 rows and then 2 columns. We can also have matrices which are like let's say 3 comma 2 or 4 comma 2 and all these orders, which are basically how we change the rows and columns of the matrix. So if I have write to B is equal to, let's say 2 3 2 1 0 minus 1. So in this case we have 2 rows and 3 columns, right? 1 2 3, we have 3 columns and we have 2 rows. So that's why we write 2 cross 3. It's a convention that we use. First, always write the number of rows followed by the number of number of columns, and this is called as the order of a matrix. So the order of B matrix is 2 cross 3, order of A matrix is 2 cross 2. Okay. Let's move on. Let's understand where do we use matrices? A simple example can be, let's say a person says, let's say we count the number of cows, and let's say we count the number of hens, and there are, let's say, two farms, correct? Let's say we have a farm A and let's say we have farm B. Then let's say if we have two cows and let's say we have three hens on the first farm, and let's say we have four cows and let's say we have 10 hens on the second farm. So this is how matrices help store data in a ordered manner. We have clearly understood how many like it's quite detailed, right? We can understand that this 2 is the number of cows in A. This 10 is the number of hens in B. So it's in an ordered form. The one more thing that we should understand in matrices is usually that we write the elements in this form. So let's say I would say E11, then I'll say E12, then I'll say E21, and then I'll say E22. What is this E11, E12, E21, E22? E stands for, let's say, element. An element in the first row and first column is basically 2. Okay, so what I usually like to say that E11 is the address. And what is the address? Address is the first row and first column. Okay, and who is there in E11? So who lives in that address? So 2 lives in that address. Similarly, if I say 3 is E12. So 1, 2 is its address. 3 is in the first row and second column of the matrix. Okay, so this is how we can write 2, 3. So similarly, if I say 4 is the element in the second row and first column. Correct? This is the first row. This is the second row. So E21 is basically element in the second row, first column is nothing but 4 here, and 10 is nothing but E22. Okay, so its address is 2, 2. So this is the basics of matrices, and maybe we'll use this example of cows and hens on two farms A and B more often to understand how matrix operations usually work. So let's understand how many types of matrices there are. So these are some basic types of matrices that we have. For example, this first type is called as column matrix. So in column matrix, you have only one column. Okay, so example of a column matrix is like 1, 2, 3. We could have any number of rows, but only one column should be there. So this is example of a column matrix. Okay, so we can easily understand what row matrix is. A row matrix which has only one row. Okay, and that row can be written as simply 1, 2, 3. What is a square matrix? Square has the length and breadth of a square are equal. So number of rows equals the number of columns. Then you get a square matrix. Example is simply, let's say if I say 1, 2, 3, 4. So this is a square matrix which has order 2 cross 2. It has 2 rows and 2 columns. What is a diagonal matrix? Diagonal matrix is a square matrix whose elements of the diagonal are not 0, but all other elements except diagonal elements are 0. Okay? Whose all elements except diagonal is 0. So basically I could say 1, 2, 3, but then 0, 0, 0, 0, 0, 0. So this is example of a diagonal matrix because it has only elements in the diagonal and it has to be a square matrix. So this is a square matrix of order 3 because it has 3 rows and it has 3 columns. Okay. What is a scalar matrix? So scalar matrix is a diagonal matrix whose diagonal elements are same. So I'll simply give an example of a scalar matrix as, let's say, 1 1 1. Okay, let's say I say 2 2 2, 0 0 0, 0 0 0. So this is a scalar matrix which is a diagonal matrix which has all the diagonal elements of the matrix are same. This is an scalar matrix. Okay. If the elements of the scalar matrix are 1, then we get an identity matrix. So identity matrix is basically 1 1 1, 0 0 0, 0 0 0. It can also be of 2 cross 2 form. So for 2 cross 2 it is simply 1 1 and 0 0 like that. And a 0 matrix is a matrix whose all elements are 0. Okay, so these are the types of matrix. I've covered them very quickly. If you want to get more details about it, just refer your textbooks. And let's solve a few questions here. Let's say the first question is to construct a 2 cross 2 matrix whose elements are given by this form. Okay, so I and J are nothing but the parameters of rows and columns respectively. So let's say if it is a 2 cross 2 matrix, so I is the row and J is the column. So I can get two values, I is equal to 1 and I is equal to 2. Well, J can also get two values, J is equal to 1 and J is equal to 2. So basically the address that we get here is nothing but A11, A12, A21 and A22. So the elements that live at this address is given by that equation. So we can simply substitute and find out what A11 is. A11 is nothing but 1 plus 2 into 1 whole square by 2 is nothing but 3. 3 square is 9. So it is 9 by 2. Similarly, A12 is not what? It's simply 1 plus 4's whole square by 2, which is 5 square by 2, which is 25 by 2. A21 is nothing but 2 plus 2 into 1 whole square, which is 4 square, which is 16 by 2, which is nothing but 8. And A22 is, what is A22? A22 by 2, yeah, A22 is 2 plus 2 into 2 whole square by 2, which is 2 2 is 4, and 4 plus 2 is 6. 6 square is 36. 36 by 2, which is nothing but 18. So I can construct the answer of first question is nothing but I can construct the matrix like this. So 9 by 2, 25 by 2, and 8 and 18. So this is the answer of first matrix. Okay, I hope it's clear. Yeah, we just have to, okay, let me not do that. We just have to understand what it is. Okay, let me just clear these things. Okay, so this is the first answer. Okay. Similarly, I could solve the second question. Second question can be solved by, let's say, Aij is given by the equation of 2i minus j. And how many elements will we have for the 3 cross 4 matrix? We'll have 3 4s are 12 elements. So the values that I can take, not me, not I don't mean me by I, but the element, let's say, or the variable I, that it can take values like 1, 2 and 3, correct? Since I is written first and j is written second, so firstly we can take 3 rows because they have given that there is only 3 cross 4 elements in the matrix. And similarly, j can assume how many values? J can assume 4 values. J is equal to 1, j is equal to 2, j equal to 3 and j equal to 4. If I were to directly solve it, just remember you have to just subtract 2 times the first the element at the first row and followed by the column. Okay, it's difficult to explain, but it's very easy to do is what I'll say. Okay, so just put the values of I and put the values of j to get your element respectively. So I'll simply put it 2 ones is 2, 2 minus 1 is 1, so I'll get 1 in my first row and first column, followed by 2 ones is 2, but 2 minus 2 is 0, 2 minus 3 is minus 1, 2 minus 4 is minus 2. Okay, so 2 2s are 4, 4 minus 1, 4 minus 1 is 3, 4 minus 2 is 2, 4 minus 3 is 1, 4 minus 4 is 0. Then let's put 3, 3 2s are 6, 6 minus 1 is how much? 5. Then we'll get 6, 6 minus 2 is 4, 6 minus 3 is 3, 6 minus 4 is 2. So this is the answer of second question. Okay, and simply the third equation says that it basically has two matrices which are equal. So if two matrices are equal, then the elements then all elements should be equal. So A minus B is nothing but minus 1, then 2A plus C is 5, A minus 2A minus B is 0, and 3C plus D is 30. So let's equate them. So if A minus B is minus 1, then I could simply say that A is equal to B minus 1. Also, from equating the 2 comma 1 element, I'll get 2A minus B equals 0. So I'll get B is also equal to 2A. Okay, I could simply substitute it in this equation here to get the value of A, and then what I'll get, A is equal to 2A minus 1. So minus A is equal to minus 1, so A is 1. So if A is 1, then B is 2. So I found the values of A and B. Let me put it in the 1 cross 2 element. So 2A plus C is 5. So I can say 2 plus C is 5, so C is 3. And how can I find B? I can simply equate this element with this. So I'll get 3C plus D is 13. So 3C is nothing but, what is 3C? What is C? 3. So 3 is a 9. 9 plus D is 13. So D is 13 minus 9, which is 9, 10, 11, 12, 13. So it's 4. Okay. So I've got the values of A, B, C, D. How funny it is. It's simply 1, 2, 3, 4. Yeah, who would have thought? So this is how you solve the basics of matrices. If you have the basic understanding of rows, columns, and then the addresses of those elements, then it's good to go. You can understand matrices. It's a simple chapter. You just require a bit of practice, and then you are good to go. Let's move on to the operations on matrices. What operations can we use on matrix? So the following are the operations of a matrix: addition, subtraction, transpose, scalar multiplication, followed by matrix multiplication. So what is addition of two matrices? So I can simply say, let's say we take back our example of cows and hens on two farms. So let's say cows, hens, yeah, and farm A and farm B. So let's say we have 2 cows on the first farm. Let's say we have 3 hens on the first farm. Let's say we have 4 cows on the second farm. Let's say we have 10 cows on the second farm. So let's say this is what we have our first matrix, and let's say we add two cows on each farm. Yeah, so what we are doing is we are adding 2 cows. Are we adding any hens? No, we are not adding any hens. We are also adding 2 cows in the second farm. We are not adding any hens. So we basically get 4 cows in the first farm. We get 3 hens because we don't change the number of hens. We get 6 cows on the second farm, and we don't change the number of hens. So this is what we get. So this is simply the addition of 2 matrices. What we do is we simply add their respective elements. So if we have 2 here, then we add 2 plus 2 is 4. We have 4 plus 2 is 6. 3 plus 0 is 3. 10 plus 0 is 10. So that is how addition works. Subtraction works in the similar way. Let's say if I have 2, 3, 4 and 10, and if I subtract, let's say, one cow from the first farm, let's say let's say make all the 3 hens disappear from the first farm. Also we subtract all 4 cows from the second farm, and let's say we subtract all 3 hens from the second farm. So what we are simply doing is 2 minus 1 is 1, 3 minus 3 is 0, 4 minus 4 is 0, 10 minus 3 is 7. So this is how we subtract. Okay. So addition is done, subtraction is done. What is transpose? So transpose is basically if somehow I were to flip the matrix so that it changes its meaning, that is what is transpose. So the transpose of this is simply, I have to write cows here and hens here, okay, and I have to write the farm A here and farm B over here. So how many cows are there on farm A? So there are 2 cows. How many hens are on the farm A? The farm A has 3 hens. How many cows on the farm B? Cows on farm B were 4. So 4 cows here and simply 10 hens on. So this is what transpose means, that we have to flip the rows, we have to make the row, we have to make this column into a row and make the row into a column. Yeah, so 2 and 3 came here and 2 and 4 came here. That is how you transpose a matrix. This is an example of transforming a 2 cross 2 matrix. But similarly, we could transform a 3 by 3 matrix also. Let's say we have 1, 2, 3, 3, 2, 1, 0, 1, 0. And if I have to transpose this matrix, then the operation we use is, we say T. So transpose of this matrix is equal to 1, 2, 3. The first row became the first column. The second row becomes the second column, 3, 2, 1, followed by the third row becoming the third column, 0, 1, 0. So that is how you transpose a matrix. Okay. So let me clear it out. I hope it's clear. It's all very easy. So that's how we are done with transpose also. Let's talk about scalar multiplication. So what is scalar multiplication? Let's say the same example that I have, let's say, cows, hens, okay, and let's say we're talking about farm A and farm B. I shouldn't have erased it, I know, but whatever. Let's say I have 2 cows, I have 3 hens, I have 4 cows, I have 6 hens. I have to scalar multiply it. So if I say the next year I have doubled all animals, right? So what I'm doing is I'm multiplying 2 with the whole matrix 2, 3, 4, 6 to get what will I get? So if I doubled all animals, so cows will also get doubled. So it is 4, 6, 4 to the 8 and 6 to the 12. So this is how scalar multiplication of matrices work. You simply have to multiply each and every element with the scalar which is outside here. Okay. You can also basically say, okay, let's say if I've got this and then I say I halved all cows, correct? So what I'm doing is 4, 6, 8, 12, I am multiplying it with half so that I get 2, 3, 4, 6. We can also think it like a basic algebra. The 2 is in division here, it goes there to get multiplied. So if you multiply 2, 3, 4, 6 this matrix with 2, then you get this, and vice versa. If we divide it by 2, then we will get it. So this is how scalar multiplication works. It's very easy. Let's move on. Let's talk about matrix multiplication of a matrix, how we multiply 2 matrices. So let's get our cows and let's say hens back. So a simple way to understand how matrix multiplication works, usually people find it a bit confusing. I'll tell you I'll give you a perfect example. Let's say bring our cows back. Let's say we bring our hens back, and we have a farm A here, followed by a farm B here. Let's say 2 cows here, 4 cows here, 10 hens here, and let's say 5 hens here. If someone were to ask you how many legs are there on the first farm, how many legs are there on the first farm? Yeah. So yeah, we know that each cow has 2 legs. No, not 2 legs. I'm sorry, 4 legs. And each hen has, let's say, 2 legs. Yeah. So how many legs are there on the first farm, and how many legs are there on the second farm? Can you solve it simply? So how can you solve this? Yeah, you would say like there are 2 cows on the first farm. Yeah. Okay, let me write it down what I'm wanting. So let's say I want to find the number of legs on farm A and farm B. So what can you say? You can say that the first farm has 2 cows and 1 cow has 4 legs. So you'll say 2 cows must have 8 legs. And you can say that there are 10 hens on the first farm and each hen has 2 legs. So 10 2s is 20, correct? So you'll say that basically we have 8 and 20. So you say we have 28 legs on the first farm. And similarly, you can say 4 into 4 plus 5 into 2, which is 16 plus 10, which is basically 26. You could say that there are 26 legs on farm B, correct? So what you have done basically is matrix multiplication, where the matrices that you are multiplying, its rows, yeah, and number of columns should be the same. Wait. So what I'm trying to say here is, like, we have 2 rows and 2 columns in the first matrix. We have 2 rows and 1 column in the second matrix. Yeah. The first row represents farm. The first 2 rows represents the farm. The 2 columns represents animals. And in the second matrix, the 2 rows represents animals. Yeah. So cows and hens, and the column represents legs. Correct? So when you multiply these matrices, the animals kind of get multiplied, and what you're left with is farms and legs. And this is what you get basically. You got farms here and legs here, correct? You get the rows of farms and you get the columns of legs, correct? And hence, so that is how we multiply the matrices. I hope I have not confused you. It's quite simple, it's quite intuitive. Basically, what you have to do is, if we have a row, you have to multiply that row with a column, okay? And then add the individual multiplications, okay? Then for the next element, you have to do the same, second row with again that column, and again you move ahead. So that is how you multiply matrices. Okay, let's do one more question. Let's say we do one more question. Okay, let's say this time let's have, okay, the important thing while multiplying matrices are, okay, so let's say if I'm multiplying A matrix with B to give me a C matrix, then the number of columns, yeah, so R1, so let's say RACA This is the order of the first matrix, and let's say I have RB and CB. So the number of columns on the first matrix should be equal to the number of rows on the second matrix. Then only you will get a valid multiplication, and the number of rows in the resulting matrix will be the number of rows of A and the number of columns of B. So this is how you get a matrix multiplication. Okay, let's do one more question. I hope it clears your doubts if there are any. Okay, even if there are some more doubts, you can simply maybe comment it down below. I'll answer it if possible. So let's say I have, let's go back to our example of cows, and yeah, so let's say I have cows, hens, farm A, and let's say I have farm B. Yeah, so let's say 2 cows in the first farm, 5 hens in the first farm, 3 cows in the second farm, and let's have 10 hens in the second farm. And this time what I want to do is I want to multiply it so that I get to understand how many legs, how many, let's say, horns, yeah, and let's say how many what can we say, let's say beaks. Yeah, so we know that legs, if we are talking about legs, one cow, sorry, this is not chicken, this is cow. So one cow has 4 legs, correct? And one hen has 2 legs. Okay, if you're talking about horns, so a cow has 2 horns, a hen has no horns. If you're talking about beaks, then the cow has no beaks, but the hen has 1 beak. So if you want to find out how many legs are there on the first farm, so how can we find the number of legs on the first farm? Well, simply because cow has 4 legs, yeah, and hen has 2 legs. So I can say 4 2s are 8 and 5 2s are 10. So I can simply say 8 plus 10. So I have 18 legs on the first farm. Similarly, if someone asks you how many horns are there on the farm, yeah, so there are 2 cows and there are 2 horns on 1 cow, so there has to be 4 horns. Yeah, so I'm multiplying 2 with 2. I'm multiplying the row with the column, basically, is what I'm doing. So 2 2s is 4, and hens have no horns. Yeah, so I'll add it with 5 times 0. Okay, and if I have to calculate the number of beaks, so similarly I could say that, yeah, what I could say, that there are no beaks, that cows don't have beaks, but 5 hens have 5 beaks, so 0 plus 5 is, that's how I get the number of legs, the number of horns, and the number of beaks on the first farm. Okay, similarly for the second farm, I'm doing the same thing. I'm multiplying this row with the column. So 4 3s is 12 and 10 2s is 20. 20 plus 12 is 32. Okay, so I've got 32 legs. Then 3 2s are 6. I've got 6 horns and 10 beaks. Okay, so I hope it clears if you have any misunderstandings about let's say, yeah, if you have any misunderstandings about matrix multiplication, I hope it clears it out. Okay, so now let's understand some elementary transformations. So what are elementary transformations? Let's say we go back to our original question. Yeah, so in this question what we had basically was, we had 2 cows, 5 hens, 3 cows, 10 hens, and we multiplied it with 4 2 0 2 0 1 to get a matrix which is basically 18 4 5 10 6 and 32, correct? Okay, so if I were to interchange the farms, okay, yeah, if I were to interchange the farms, you know, it's quite obvious that the rows in the answer would simply get swapped. It's not necessary that the values will change, yeah, because the maths is still the same. Well, cows still have 4 legs and hens still have 2 legs, right? So this matrix won't change, but if we interchange the farms on the left, so we also get the interchanged answer on the right, correct? So simply if I were to let's say switch the rows in the first matrix, if I were to, let's say, tell 3, 10, 2, 5 here, not changing the number of legs or the number of horns or the number of beaks, we would still get, what would we still get? We would still get the same result, but the rows will only get changed, correct? So this is a row transformation. If we have to transform the rows, we should transform the rows on this side of the matrix and this side of the matrix. We don't have to transform the rows of the, let's say, yeah, correct? We don't require to do that. You can try multiplying it out, you will still get the same answer. So in elementary transformations, basically we have row transformations and column transformations. And in row transformations, let's say if I have A into B, let's say it gives us a C matrix. So we can do row transformations to A and C, not B. Okay, you don't have to transform the B matrix because it doesn't basically matter that much, correct? Similarly, if I were to transform these order, let's say if I interchanged beaks, if I put the legs at the last and let's say beaks at the first, then the final answers, beaks and legs, would also get interchanged, right? So we can only transform these two. So in column matrix, if I have A into B to give me a C, I could apply column transformations to B and C, but I don't have to apply column transformations on A. Okay, so I'll say transform the rows of pre-multiplier and answer. Yeah, this is, I could say A is the pre-multiplier because it's before B. Yeah, pre-multiplier and C, and your, not C, but your answer, correct? But in case of columns, transform the columns of post multiplier. In this case, our post multiplier is B. In this case, pre multiplier is A and answer is basically C. Post multiplier, who is our post multiplier? Post multiplier is B and answer is C, correct? So that is how rows and column transformations works. And with the help of these rows and column transformations, we can study how inverse of a matrix is found out. To find inverse of a matrix, first thing that we have to understand is when we apply row and column transformations, we are simply using all these operations that we had studied earlier. And most prominently, what we are going to use is scalar multiplication, and addition and subtraction is what we are most probably going to use. So let's understand how to find inverse of a matrix with the help of an example, and this is the example. The example says that if we have 2 ice creams and 3 chocolates, it costs rupees 35, and 4 ice creams and 1 chocolate costs rupees 45. Then find the price of 1 ice cream and 1 chocolate. Okay, let's say if we don't know matrix, if we don't understand what matrix is, it's a simple simultaneous equation problem which has 2 variables and 2 equations, correct? So what are the 2 variables? I would say the first variable, let's say I'd say x. X is the cost of 1 ice cream, correct? And what is y? Y is the cost of 1 chocolate. So what is the first equation? Well, we know that we have two ice creams, so I'll say 2x plus 3y is 35. This is our first equation. And what's the second equation? Second equation basically says is we have 4 ice creams and 1 chocolate. So 4 ice creams means we have 4x plus y is basically 45. So these are the two equations that we have. Okay, without doing simultaneous equation, let us try to understand it in a matrix form. And how can we do it in a matrix form? Well, why don't we simply put brackets here? Okay, we are going somewhere. And we have understood that there are 2 rows and 1 column in this, but here we have, let's say, simply 1 column, I know you have also 2 rows. Why not write it like this: 2 3 4 1. Well, this first column represents the number of ice creams and the second column represents the number of chocolates, correct? Let's say we have 2 students. Let's say this is the first student A and this is the second student B. So A has 2 ice creams and 3 chocolates. And then how many rupees has A spent? So A has spent 35 rupees, whereas B has spent 45 rupees. But this is not a correct equation because we are missing this x and y, which is the cost of. This is the cost of what? It is the cost of 1 ice cream. 1 ice cream costs x and 1 chocolate costs y. So now it makes sense that x is the cost of ice cream and y is the cost of chocolate, and this is, let's say, in rupees. So finally what we are getting is I'm sorry, let me just write it over here. Okay, so finally what we are getting is this equation in a form of matrix. So to understand how row and column transformations work, let's just write down this matrix here like that. What we have here is 2 3 4 1. X and y gives us what? 35 and 45. Right? This was our equation. So it's quite clear that if we interchange or if we do any kind of transformations on these rows, it won't affect the cost of 1 ice cream and 1 chocolate, but it would quite interchange the rows or whatever transformation we do on the answer, correct? As we had mentioned earlier, since A is the pre-multiplier, and if we are transforming any rows, then C will also transform, but B will not change. We can say that this is our A matrix. A into B is giving us a C matrix. So if we do any row transformations on A, we will have to do the same row transformations on C. So what are we trying to achieve? Well, we are trying to achieve an inverse. Let's say somehow if A becomes identity matrix, somehow see, matrix division is not possible. Simply if we want to find B, why cannot we do B is equal to C divided by A? Because it's not possible. We cannot divide matrix. But we can do the next best thing. We can multiply C with an inverse of a matrix of A. So A inverse into C will give you the same kind of answer which we hope to get from this thing, correct? And how can we achieve A inverse? We can only achieve A inverse here if we somehow kind of disappear this A from the LHS, right? So how to make this A disappear from the left hand side and take it to the right hand side? Well, what we do is we simply want to make it 1, and 1 in terms of matrix is nothing but our identity matrix that we had studied earlier, correct? This identity matrix. So this is our basic goal. We want to transform A into this identity matrix, because if it becomes identity matrix, what we are left with is basically B. So I into B will give us A inverse into C, and A inverse into C will be our final answer, which is nothing but our B. Correct? So that is how we can achieve to solve this equation, right, with elementary row transformations. So let's try to solve it, and let's try to understand what we are doing here. So we only have to do row transformations, we cannot do column transformations here. So somehow we want to make 2 3 4 1 into I matrix is nothing but 1 0 0 1. We want to somehow transform this matrix into this matrix. How can we do it? Well, let's say first of all, let's say we try to make the second row's first element to be 0. So I'll write the equation as R2, which is our, let's say, our new R2. Let's say it becomes our old R2 minus 2 times R1. Yeah. If we do this, what would happen? It would be simply, we are not changing the first row, so 2 and 3 will be the same, but the second row is changed as 4 minus 2 times 2 and 1 minus 2 times 3. X, Y equals, doing the same row transformation on the C also. So I'll write 35 over here, and what can I write over here? I'll write simply 45 minus, let's say, 2 into 35. So what did I get from my first transformation? From my first transformation, I got 2, 3, 0, and 3 2s is 6, correct? But 6 times 6 minus 1 is minus 5. So minus 5, I've got it over here. And xy is equal to, what's left over here? It's 35 and 45. 35 2s is 70. So 45 minus 70, it's how much? It's 25, right? So minus 25. So this is what we are left with. And similarly, we want to transform, let's say, we want to transform this 3 also. We also want to make that 3 into 0. So what can we do? Well, let's say we multiply the first row. The LCM of 3 and 5 is 15, correct? So let's say we multiply R1 with 5, and R2 becomes thrice. Okay, so that new transformation will give us a matrix which is 2 5 is 10, and this becomes 15, correct? And now we have simply, what do we have here? We have let's say, this is, what is this? This is 0, but then we get here is minus 15 xy. I know a lot of you guys will be tempted to simply solve using simultaneous equations, which is easier, is what I'll say. It is easier compared to this, at least in this question. Yes, but let's not lose our patience here. There are better ways to find inverse and better ways to solve this equation, but it's not. It's better to keep it in our in our reserves, right? If we know an extra method to solve a question, it's not a bad thing, right? So let's try doing it. So what we can do here is doing the same transformation. 35 5 is 5 is 25, and 5 is 15, 16, 17, 175 over here. And what do we get over here? We get is minus 25. Minus 25 into 3 is minus 75. So this is what we are getting. And now simplifying it even further, yeah, we can simply add it, yeah. let's say we say R1 becomes R1 plus R2, then what we get is we add 10 with 0, so it becomes simply 10. Yeah, but when we add 15 with minus 15, we get a 0 over here, we get a 0 over here, and we have minus 15 over here, and x and y are the same. And what do we get over here? We get 175 minus 75, so we get 100 over here and minus 75 over here. So this is what we get. Okay, and now let's say simply we say R1 gives, let's say, becomes R1 divided by 10, and R2 becomes R2 divided by, let's say, minus 15. Yeah, so what do we get over here? If we divide it, what we get is, it becomes 1 0 0 1. It becomes a matrix. Yeah, this became an identity matrix. And what do we have here? X and y, and output will be 100 divided by 10 is nothing but 10, but 75 divided by 15 is what? It's 5. Yeah, so basically what we got is, we found out what the cost of each item is. Yeah, so basically what we found out is x and y are the two elements which are equal to what? 10 and 5. So the cost of one ice cream was basically rupees 10, and cost of one chocolate was rupees 5. Okay, so this is how we found out using elementary transformations. Yeah, we didn't actually calculate A inverse here. Yeah, we can calculate A inverse, but we actually did not calculate A inverse. We kind of bypassed that step. We did not need to actually calculate A inverse. What we actually found out was A inverse into C. So this answer, which is basically 10 and 5, that is nothing but A inverse into C. Okay, so A inverse into C is nothing but our 10 and 5. Okay, so we kind of bypassed A inverse, but A inverse can be found out in the similar fashion. Okay, let's say if we didn't want to bypass A inverse, and let's say if we want to compute A inverse, then how can we compute A inverse? Let's find out. Okay, so to find out A inverse, let's say we can by, let's say, row transformations, we can have two ways. Okay, so as I said earlier, for row transformations, we can transform this side, we cannot touch this one, and we can transform that side. So I can say A into A inverse is equal to I. This is the property that I'll use for row transformations to find out A inverse. I'll use row transformations on A, and I'll use row transformations on I, and try to convert A matrix into I matrix so that I matrix becomes A inverse. Okay, the same thing that we did over here is what I'll try to do over here. And for column transformation, if I want to find out A inverse, I use A inverse into A is equal to I. So I'll try to do column transformations on A and column transformations of I. Try to convert A to I so that I becomes A inverse. Okay. Yeah, I know it might sound confusing, but it is not really that confusing. Let's take this example so that we can also verify what our original thing was. So let's say we have 2 3 4 1. So let's say our first A matrix is nothing but 2 3 4 1, and let's say if we are using row transformations, I'll use A into A inverse is equal to I. So I'll write 2 3 4 1 into A inverse is equal to I is nothing but 1 0 0 1. Yeah, and I'll use the same set of transformations that I used over here. What is the first transformation that I used? I used R2 equal to R2 minus 2R1. So I'll write R2 equals R2 minus 2R1. So what I'll get? I'll get this matrix over here, 2 3 0 minus 5. So I'll write 2 3 0 minus 5 A inverse but I have to use that transformation over here. What will I write for R1? Let's say 1 0 is for sure, but then R2 minus 2R1, so it becomes minus 2 over here, and then minus 2R1. R1 is what? What is R1? R1 was 0 here. Okay, so it won't change, so it will be still 1. Okay, then what is the next transformation that I used? R1 became 5 times R1. No, I'm sorry. Yeah, sorry. R1 becomes 5 times R1, R2 becomes 3 times R2. R1 becomes 5 times R1 and R2 became. There is a very easier way to do this. For 2 cross 2 matrix, we can bypass all these things. I directly tell you the method. Well, let it be. We'll study that method, a simpler method in determinants, when we study about determinants. But for the timing, let it be like that. And R2 becomes what? R2 becomes 3 times R2. So I'll write 3 times R2. So the matrix became this thing: 10, 15, 0, minus 15, 10, 15, 0, minus 15. A inverse is equal to what? So this 5, 0, and it became minus 6 and 3, correct? Then obviously I know the next transformation. I'll say R1 became what? R1 plus R2, and R1 became R1 plus R2. It becomes 10, 0, 0, minus 15. A inverse is equal to what? So this becomes minus 1, this becomes 3, this becomes minus 6, this becomes 3. Yeah, and then I'll simply say R1 is R1 divided by 10, correct? So I'll write R1 equals R1 divided by 10. Yeah, this is what I used, right? Yeah, R1 became R1 by 10 and R2 became R2 by minus 15. So what can I write over here? I'll write 1, 0, 0, 1. A inverse is equal to, it's what is this? It's minus 1 by 10, 3 by 10, minus 6 by 15, and 3 by 15. This is what I got over here. Okay, so yeah, so this is the A inverse of that matrix. And correct me if I'm wrong, maybe it's quite possible that I have done some calculation mistake over here, but try doing it on your own, then you will get a better idea how to do A inverse. So this is the A inverse of the matrix, and when we multiply A inverse with this matrix over here, 35, 45, what we are bound to get is basically A inverse into C is nothing but 10 and minus 5, 10 and 5. Okay, so that is how you compute that. Okay, let's do one more question over here. This is a bit bigger question because it has 3 variables now. Now it is quite possible that instead of doing simultaneous equations, probably our inverse method would would become easier. Let's do this one. Okay, so let's say you have got to have 2 ice creams, 3 chocolates and 1 mango. Cost rupees 55. So I can say 2x plus 3y plus z is equal to 55. The next equation is 4x plus 2y equals 50 and 2x plus 2y plus 2z equals 70. So this is the equation that we have. Okay, let's simply okay, they are asking to do column transformations. So for column transformation, we would write xyz in the first row because we don't want to change xyz. So if we write xyz over like this, then what can we write for that thing? Okay, how can we write this matrix? Well, we have to we have to kind of do a transpose. We have to write 2, 3, 1. Yeah, because it will, then we'll get 2x and 3y and 1z. Yeah, this is the first equation. Followed by the second equation will be 4, 2, 0. Correct? And the third equation will be 2, 2, 2. So by multiplying these two, what we want to get is, we want to get 55, 50 and 70. Yeah. So let me simply write it down. That is equal to 55, 50 and 70. Okay. So this is our A matrix, this is our B matrix, and this is our C matrix. And what we want to do is, we want to find out A. So A into B is equal to C. So to find A, we want to post multiply it with A inverse. So we want A into I is equal to C into B inverse. So that is how we can find B inverse. So either what we can do is find B inverse individually, then multiply it with the C to get our A matrix. So let's do that. And for doing that, what can we use? Or directly you could bypass B inverse and directly calculate what is C into B inverse directly by doing column transformations. But let's say we are not interested in doing that. Let's say we want to find out what is B inverse first. So I'll write down B inverse into B is equal to I. So I'll try to convert B to I so that I becomes B inverse. Okay. So let's say B inverse into B. B is, what is B? B is 2, 3, 1, 4, 2, 0, 2, 2, 2. Is nothing but I is what? I is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So what can be our first column transformation? Since we have to use column transformations, what column transformation can we use? Okay, let's try to get as many zeros as possible first. Let's say I subtract the first, let's say the third column from the first column to get a zero over here. So I'll write C2 or C3 becomes C3 minus C1. Yeah. So what happens? I'll say B inverse equals, so let's say 2, 3, 1 is the same thing, 4, 2, 0 is also the same thing, but 2 minus 2 becomes 0, and 2 minus 3 becomes minus 1, and 2 minus 1 becomes 1. Yeah, B into B, this thing is equal to what? And in this thing we have 1, 0, 0, 0, 1, 0, and if we subtract it, what we'll get is minus 1, 0, 1. Okay, it's a long procedure, no doubt, but you can have patience, and yeah, we'll be able to do it. Yeah, so let's say I'll write B inverse into, what is this? 2, 3, 1, 4, 2, 0, 2, 3, 1, 4, 2, 0, and 0 minus 1, 1, 0 minus 1, 1 equals, what is it equal to? 1, 0 minus 1, 1, 0 minus 1, 0, 1, 0, 0, 0, 1. Okay, so what can we do next? Let's say we want to convert this 4 into 0. So how can we convert that 4 into 0? We'll write C2 becomes C2 minus 2C1. Yeah, because 2 2 is 4, so 4 minus 4 becomes 0. So what we'll get is B inverse into, we'll have 2, 3, 1. First row will be, first column will be the same, third column will also be the same, but the change will be 4 minus 4 is 0, 2 minus 6 will become what will 2 minus 6 become? Two minus 6 will become, what will it become? Yeah, it happens sometimes with me. So 2 minus 6 is minus 4. Yeah, and then we have minus 2 over here. Okay, it is equal to what? It is equal to 1 0 0 minus 1 0 1, but then I have to subtract it, correct? So what will it be? Minus 2 1 and 0. Yeah, okay, so that is done. So we found our two zeros over here. The next step is to make this fellow 0 and also to make this fellow 0. So how can we do that? So let's say to do that, let's say we'll make that thing. Okay, so let's say we do C2 equal to C2 becomes, not C2, let's say C3 becomes minus 4 times C3. So I'll multiply C3 with itself with minus 4. So what will it be? I'll get B inverse into 2 3 1 0 minus 4 2 minus 2, and this will be 0, this will become 4, and this will become minus 4. Yeah, and on the RHS what I'll have is 0 1 0 0 minus 2 1 0, and then I'll have 4, yeah, 0 and minus 4 is what I'll have. Okay, so now what I can do is simply add it. So C3 becomes C3 plus C2. So C3, I'll add it with C2, then what I'll get is B inverse into it becomes 2 0 0 3 1 minus 4 minus 2 as it is, but I'll have to add them. So it will be a 0 over here and a minus 4 minus 2 is minus 6 over here, but on the RHS I'll have 1 0 0 minus 2 1 0 and 4 minus 2, which is 2, and this is 1, and this is minus 4 over here. So this is what I'll get. Okay, so good thing is that I found out yeah, how many 3 zeros I've got? 3 zeros. By the way, this is the hardest example. This is the height of difficult questions that you will be asked in your 12th standard exams. But whatever it might be the case, we could let it be. This is because I am trying to find B inverse. The simpler way would have been to bypass B inverse and directly find C into B inverse, and so that we could directly get our XYZ. Okay, but no, I have chosen the long path, and let it be, doesn't matter. So this is what it is. Now let's try to make this fellow into 0. And how can I make that fellow into 0? Let's say I multiply C1 becomes C1 multiplied by 4, and C2 becomes C2 multiplied by 3, so that we'll get the same LCM. So B inverse times this becomes 8, 3 4s are 12, and 4, and this is 0, 4 3s is minus 12, and minus 2 3s is minus 6, and 0 0 minus 6 as it is. And on the RHS I'll have 4 0 0 minus 6 3 0 2 1 minus 4 as it is. Okay, and now it's quite easy. I'll simply add that. So I'll get C1 becomes C1 plus C2, and then after doing that, what we get is B inverse becomes 8 0 minus 2 0 minus 12 0 0 minus 6 and minus 6 is what I'll get. Yeah, but it's not over yet, because I still have to calculate the RHS, and that's the more difficult part. Let me see what I can do. So C1 plus C2, so C1 plus C2, it will make it minus 2 3 0. Okay, minus 2 3 0. Let me write it down here, minus 2 3 0. Then minus 6 3 0, minus 6 3 0, and 2 1 minus 4 2 1 minus 4. Yeah, followed by what we had on LHS, B inverse times this thing. This is 8 0 0 8 0 0, then 0 minus 12 0 0 minus 12 0, and minus 2 minus 6 minus 6 minus 2 minus 6 minus 6. Okay, so we have achieved 4 out of 6 zeros. We also want a 0 over here, we also want a 0 over here. So let's bring this 0 because it's easier. So I'll write C2 becomes C2 minus C3. So what I'll get is B inverse into, I'll get is 8 0 minus 2 0 minus 12 as it is, but we'll get one more 0 over here, then 0 0 and minus 6 over here. Okay, and doing the same transformation over here, we'll get minus 2 3 0, but minus 6 minus 2, which is minus 8, 3 minus 1 is 2, and it becomes 4, and 2 1 minus 4 over here. Oh my god, still one more 0 we are still yet to get that one. Okay, let's do one thing. Let's say C1 becomes C1 into minus 3. Let's do that, because what will happen next is we'll get P inverse into we'll get 8 1 8 0 24 minus 24, then we'll get 0 and 6 0 minus 12 0, and 0 0 minus 6 over here. What will we get over there? We'll get 3 6 minus 9 0 minus 8 2 4 2 1 minus 4 over here. Okay, let's say this is what we got, and then simply we should do C1 becomes C1 plus C3. So simply what we get over here is P inverse into, we'll get minus 24 0 0 0 minus 12 0 0 0 minus 6, and on the RHS what we'll have is plus C3 6 plus 2 is 8 minus 8 2 minus 8 2 1 minus 4 4 minus 4. This is what we got. So close yet so far, because now the only thing that we are remaining to do is we'll simply divide. C1 becomes C1 divided by minus 24, C2 becomes C2 divided by minus 12, and C3 becomes C3 divided by minus 6. So we get B inverse into, this becomes 1 0 0 0 1 0 0 0 1. This becomes an identity matrix, is what we get here. But on the RHS what we get is 8 divided by minus 24 So it will be 8 3s are 24, so minus 1 by 3, and 8 3s are 24, so it will be plus 1 by 3, and 4 6 is 24, so it will be plus 1 by 6. And then 8 and 12, right? C2, we have to divide 8 by 12, so it will be 8 4 2s are 8, 4 3s are 12, so it will be 2 by 3. Then you will have, and what will we have here? 2 divided by 12, 2 6 are 12, so minus 1 by 6, and 4 3s are 12, so it will be minus 1 by 3, and what will it be here? It will be 2 3s are 6, so it will be minus 1 by 3, then 1 6 are 6 yeah, 1 6 are 6, so it will be minus 1 by 6, and 2 2s are 4, 2 3s are 6, so it will be 2 by 3 over here. So this is what I'll get. Let's take 1 by 3 as common. Yeah, so what my B inverse will be? My B inverse will be 1 by 3. If I take 1 by 3 common, it will be minus 1 half, then 2 minus half minus 1, then minus 1 minus half and 2. This is what I'll get. This is my B inverse. So if this is my B inverse, what can I do here? Well, I found out B inverse. We did not bypass the original equation, right? So what we'll do here is we'll simply solve it. How will we solve it? Yeah, we'll put it. See, we have to find this thing, C into B inverse. So what will it be? It will be if C into B inverse is basically 55 50 75 no sorry 70 multiplied by 1 by 3 times this whole thing. And what is that whole thing? Minus 1 1 half, minus 1 1 half, then 2 minus half minus 1, 2 minus half minus 1, and minus 1 minus half and 2, minus 1 minus half and 2. So let me quickly multiply it. So it will be 1 by 3 since it's a scalar, so I will keep it away. So it will be minus 55, yeah, plus 50, and 70 by 2 is 35 plus 35, followed by 55 2 is 110, minus 25 minus 70, and then followed by the third thing is minus 55 minus 25 plus 140. Yeah, so this is what it is. Is it correct? Hopefully it should be 1 by 3 times. It becomes this becomes minus 5, so minus 5 plus 30, so it becomes okay, minus, okay, so it becomes 30, then 70 minus 110, it becomes 40 minus 25, it becomes 15, and 5 6 7 8 80 90 100, and then 60, so it will be 60. So if I divide it by 1 by 3, what will I get? I'll get 10, 5 and 20. So this is what is our A. So this is the cost of it. We went the very long way. We found out what B inverse was, and we multiplied that B inverse with C to finally get our A matrix. And that means how many rupees? So one ice cream was how many? 10 rupees, one chocolate was 5 rupees, and one mango was 20 rupees. So this is how you calculate. It's very lengthy method, but yeah, you have to be patient, you have to be careful, and that's how you are going to be able to solve it. There is no other way. If you are okay, it only asks this method, they only ask this method in board exams. Don't worry, you have your determinants method by chance if you have to solve it the other way around. Let's quickly talk about symmetric and skew symmetric matrices, and then we'll finish our lecture. So in simple words, what symmetric matrices are, if, okay, let me write it down over here. So if A is equal to A transpose, if both are equal, then that matrix is symmetric. And skew symmetric matrix means if A is equal to minus of its transpose. Okay, don't confuse yourself with what transpose is and what inverse is. Inverse is like a kind of a division operation, whereas transpose just turns your rows into columns and columns into rows. So this is what symmetric and skew symmetric matrices are. And there is a fundamental property of all matrices. For example, if I have a matrix A as 1, 2, 3, 4, yeah, so is it a symmetric matrix? No, because if I do the transpose, it's not equal, correct? But let me still do its transpose. So what is A transpose? A transpose is 1, 3, 2, 4, correct? Okay, let me add these two matrices. So what A plus A transpose will give me? A plus A transpose will give me, let me add them. So 1 plus 1 is 2, 2 plus 3 is 6, not 6, sorry, my bad, 5, 3 plus 2 is also 5, and 4 plus 4 is 8. This is a symmetric matrix. Okay, so for any random matrix A, if we add it with its transpose, we will always get a symmetric matrix. And what if we subtract it? So what is A minus A transpose? So A minus A transpose is 1 minus 1 is 0, 4 minus 4 is 0, then 2 minus 3 is minus 1, but whereas 3 minus 2 is 1. And if we transpose it, it is actually a skew symmetric matrix. Okay? So this is a skew symmetric matrix. And a common property of any matrix which is not a symmetric or skew symmetric is A can be written in terms of this two matrices, which is nothing but half of symmetric matrix. Symmetric is nothing but A and A transpose, plus half of skew symmetric, which is A minus A transpose. Okay, so this is its symmetric part and this is its skew symmetric part. Okay, so let's so this is our last topic done, and with this I hope you guys are have understood what matrices are. So with this we terminate our today's lecture. Thank you for watching. See you in the next one.